Hydrogen is placed in group 1A of periodic table, but till now position of hydrogen is not so clear in periodic table. Look at this, hydrogen is in group 1A, but it can be placed in group 7A with fluorine, chlorine, bromine, iodine, etc. There is one strong reason that hydrogen is available in the form of gas in ordinary temperature like fluorine, chlorine, etc. That's why it can be placed in group 7A. This is an argument. And that's why one point, what can we say? It is a gas at the ordinary temperature like some halogens of group 7A of periodic table. That's why it should be placed in group 7A. Now there is another point also. Look at this. These are halogen group 7A. Fluorine, chlorine, bromine, iodine, etc. are halogens. Heli means sea salt. Genus means producer. They produce sea salt. They are called sea salt producer because chlorine combines with sodium to form a major sea salt. Likewise, fluorine, bromine, iodine also combines with metal to form some sea salt. That's why they are halogens, sea salt producer. And like these halogens, its molecule of hydrogen is diatomic. Hydrogen is available in the form of diatomic state. So we write H2 in the chemical reaction. In the same way, fluorine, chlorine, bromine, iodine, these halogens are also available in the form of diatomic state F2Cl2, Br2I2, etc. That's why this hydrogen can be placed in group 7A. So we can argue like this, like halogens, its molecule is diatomic. That's why hydrogen should be placed in group 7A. There is another reason also about the hydrogen, like lithium, sodium, potassium, etc. Lithium, sodium, potassium, etc. forms halides with fluorine, chlorine, bromine, iodine, etc. In the same way, hydrogen also forms with these metals of group 1A. And that's why we can argue like this also. Metals form halides with the halogens like sodium chloride, potassium bromide. These are the halides, metal, sodium, potassium, which are forming halides. And similarly, some metals form hydrides with hydrogen. For example, sodium hydride, potassium hydride, calcium hydride, etc. Because of this reason also, hydrogen can be placed in group 7A. There is another reason also due to which we can keep this hydrogen in group 7A. If hydrogen is placed in this group 7A just above the fluorine, then there won't be a big gap between this hydrogen and helium, and this periodic table seems to be nice. And so there is another reason what we can see, if it were placed in group 7A, there would not be a blank space for 6 elements between hydrogen and helium. These are the points which says that hydrogen position of hydrogen in group 1A of periodic table is not satisfactory. It can be placed in group 7A of periodic table.